Okay, in this video, what I'm going to do is I'm going to quickly go over the three examples, the three pulley examples, okay, in the textbook. I'm not going to go over them in detail, but we're going to look at it in a general, quick way, okay? So remember what we're trying to do is we've got one particle, we've got another particle, and it's connected to each other via some inextensible cord. And, you know, we're trying to see how the one moves in relation to the other one. So what do we do? So here we've got the problem, here we've got this block, and we've got that block, and it's connected to each other in some interesting way. And we're trying to see how the one block moves in relation to the other via an inextensible cord. Okay, so it says determine. I know it's pretty bad. The photocopying wasn't so excellent, but you can also look in your textbook. It says determine the speed of block A if block B has an upward speed of 6 meters per second. Okay, so what's the first step? We have to first set up our datum, which is our fixed point, okay, our fixed reference frame. We set it up. That's step one. Step two, determine the positions of block A. There's SA, there's SB. Notice that SB is not measured all the way down to B. It's measured to that pulley. I want to ask you, do you know why? And why can we do that? The reason we can do that is because this pulley, as this pulley goes up and down, it moves with exactly the same change in motion that block B would. So if this pulley moves up 1 millimeter, block B would move up 1 millimeter, down 1 millimeter, down 1 millimeter, okay? So there's a one-to-one relationship here. So that's why we can say block SB is measured to this pulley instead of all the way down there, okay? And also, we're measuring the lengths of the cord, right? That little cord there is not involved in the length, although that one is, okay? But nevertheless, I hope that makes sense. Okay, so remember what are we always trying to do? We're trying to get the total length of the problem. Total length between the two chords. Okay, so we've got SA plus 3SB, and that's what we get here. SA plus 3, that's your total length. Okay? Total length. You take the first derivative of that, we get this VA is minus 3 VB. Okay? So if VB moves a unit, VA moves 3 times that change in position or velocity or whatever, and in it's A's negative direction. Okay, so you plug 6 meters per second in there, but remember it's minus. You're going to say minus 3 times minus 6, and we get 18, plus 18 meters per second, meaning that A is going down 18 meters per second velocity. Okay, let's move on to this one. I'm just going to try to speed through this. Again, what are we trying to do? What's interesting about this one is we have that block and we've got block B. So we want to relate A and B to each other, right? But what you notice here, which is different, I really hope you can see that. There we go, okay? Remember, I'm recording this with my phone, so we're not a high-tech setup here. We're trying to relate block A to block B, but the difference with this is we don't have block A, block B directly related like that. We have block A, there's the one cable, okay? There's the one cable. So it's related to this pulley C. And then pulley C is related to this one here, okay? So now we've got 2 chords. We've got 2 chords, not just one. So if we've got 2 chords, it means we're going to get 2 sets of equations. Okay? 2 chords, will mean two sets of equations. So let's first look at this one. Remember, we analyze one chord at a time. Okay? Analyze one chord at a time. So let's just look at this chord. What's the length of this chord? It's going to be SA plus 2SC. And that's what we have here. That's the length of the first chord. And this chord is going to be SB. There we go. That length there is SB plus that length there, which is SB minus SC. And that's what we have there. Okay? Just going to repeat. We're looking first at this chord. That is SA plus SC plus SC. That's what we have there. SA plus 2SC is length 1. Then we have SB, that's that total length there. That's SB. Plus that length there, which is that total length, SB, minus that length, SC. SB plus SB minus SC is length 2. You take the derivative of that, we get this equation and that equation. Then, so what we've got now is we've got VA plus 2VC equals 0. That's your first equation. For that, that's for the first chord 1. And then you've got 2VB minus VC is 0. That's for chord 2. Okay? So now you've got two equations, and we have, we're trying to relate the velocity of A to the velocity of B. So we need to eliminate C. Okay? So solve for C, and then you will have A and B related to each other, and we can obtain this equation. Okay? And so just quickly, 6 meters up, we've said that the motion is positive down because SB is positive down, right? So this block is going up with 6. So the velocity of B is minus 6. I hope you see that. It's going up with 6. So velocity of B is minus 6. That's a given, right? That was given. So if we put minus 6 into there, we have VA plus 4 times minus 6 equals 0, right? I'm just taking it from there. And if we solve that, VA is 24, right? Because we move it to the other side. So VA moves 4 times VB. Whatever VB moves, VA moves 4 times. And opposite directions, right? Okay. So guys, I hope this helps. I'm not going to do the third one. I don't want to take up too much time every video, but I hope that helps. Cheers.